Alright, so in this video we are going to look at question 2, that is the Java implementation for question 2 of 9618 variant 41 of October-November 2025. Okay, so let's see here what we have. So we are given that class diagram there, and it says that a program stores data about trains and train stations using OOP, and we have the class diagram rather for the train object, or the train class as it will, and we are supposed to, we are given the fields right there, train ID, which is a string, and route, which is an integer, then of course the description of those identifiers or those fields as it were. Then for the attributes, we are going to have the constructor. We also have the get train ID and the get route, which are essentially getters for the fields that we have inside our train class as it is. Let me just zoom in a little bit. Alright, so we have to write program code that's going to declare the class train in this constructor. We are not to declare any other methods, and all attributes should be private. Then we, of course, use your programming language appropriate constructor, and so forth and so on. So we are going to do this for 4 marks. So let's look at the implementation that I have going on here. So let me zoom in a little bit so that you guys can see it better. Maybe one more time. Yeah, let me close out that sidebar there. All right, so for the class definition of our train, we have the class definition on line 38. Then inside of the class definition, we have the two private fields, the string train ID and the route, which is of type int. Then we also have the constructor right there on lines 43 to 46. We are declaring a constructor for the train class. And it's going to, so whenever we create the train object, we are going to pass a train ID number as well as a route as it is. So that's what we have going on there. Then we were told only to declare the class in this constructor and nothing else. So you would of course go ahead and copy this code and paste it inside of the evidence document as it were. Then moving on to part B, rather A, item 2. The methods get train ID and get route return the appropriate attribute. So in the case of get train ID, it's going to return the string, that is the train ID string. Then in the case of get route, it's going to return the route as it were. So let's go ahead and look at the implementation that I have going on here. So you see that I have the getters on lines 49 to say 55 there. So public string get train ID, it's going to return a string, is it? That's the getter for this one. So it's going to return our train ID number string, and the get route function or get route method is going to return the route value, which is an integer. So of course we'll go ahead and copy this code and paste it inside of the evidence document. Then moving on to part B. The program is tested with 4 trains. So train ID in the first column, then the route number in the second column. So we have those IDs for the trains: 12 ADV at route 134, 33 APT at route 20, then 9 FKF at route 3, then 21 VBC at route 24. So we have to write program code to declare an instance of train for each of the 4 trains. Then let's go ahead and implement that code. So in order to do this, we actually have to go to the main method right here, which is right there on line 6 for me. So you see that I'm instantiating 4 train objects as given here in this table in the questions. So the first train, we're going to call it T1. I say the object name is T1. Then we are calling the new train, the train constructor, right there, lines 9 to 12. So we have 4 objects of type train, each with the respective train ID number as well as the route as indicated in the requirements or in the question as it were. So for that, we can go ahead and copy the code and paste it inside of the evidence document. Then moving on to the next part of the question, which is part C. We are given a class called station. Again, it's a class diagram, and we have the attributes here. In the first section. Then in the last section, we have the constructor description, the get trains description, as well as the add train description. So let's see what's required of us here. So write program code to declare the class station and its constructor. Do not declare any other methods. So it simply means that we just want the constructor as well as these attributes right there. So let's go back to the implementation that I have down here for the station class. So you see that I have my station class declaration at line 59 there. Then of course we have the 4 attributes, string ID, then number platforms, as well as trains, which is essentially an array that's going to store the trains currently at the station platform. Yeah, then it has 10 elements, is it? Because we can see right here that it has index position 1 to 9, so it means it's going to hold 10 elements or 10 objects of type train. Then lastly, we have the number trains variable or attribute rather for this particular class. And of course, we also have to declare or create the constructor right there on line 66. You see that we have the constructor going on, right? So the constructor, according to here, it initializes station ID and number platforms to the parameter values, is it? So we have the parameter values here. Then we take these particular objects, station ID, and set it to the parameter value. And we also do the same thing for the number platforms. Then we also have to do one more thing to initialize trains to an empty array and number trains to 0, right? So number trains, that's where we are initializing it to what? To 0 over there. Yeah, initializes trains to an empty array. Where did I implement that logic there? I think I'm missing something here. All right, I think I can't seem to find where I initialized. I think I missed this part. Initializes trains to an empty array. So maybe let's take care of that real quick inside of the constructor, because the constructor is the one that's going to set trains into an empty array. So since we have trains, we know that it is an object, rather an array of 10 train objects, is it? So we can use a for loop to initialize the values or the elements to a now. So we can say int I is equal to 0, so I is short for index. So you can say I has to be less than 10, so that we can cover index position 0 to 9 as it were. Then I has to increment by 1 with each step, right? Then inside of the for loop, we can then go on to access the current index position and place a value of now inside of that particular, or rather inside of the current element as it were. Right? So this is essentially going to initialize a value of now, or make it an empty array as it were. So yeah, I think the code is now complete. I had missed this part when I did the solution on my own before recording the video, but I think that should take care of it. All right, so of course you could go ahead and then copy the code and paste it inside of your evidence document for how many marks was it? For 3 marks, is it? All right, so moving on to item 2. So the method add train takes a train parameter. Then the method compares the attributes number trains and number platforms to identify if there is a platform available. So a platform currently with no train, that is to say, that's what they mean with platform available. So the method returns false if there are no platforms available. So if there is a platform available, the method stores the train parameter in the array trains, updates the appropriate attributes, then returns true. So we have to write program code for add train as it were. So coming back here, we have the add train method right here on line 76 to 84. So remember, it's going to return a boolean true or false. So the return type there is boolean. Then add train, that's the name of the function or the method. Then it's going to take a parameter of type train. So that's what we're taking care of inside of the parentheses right there. Then we are checking to see if the number of trains is greater than the number of platforms. Because here it says that we need to check to see if there's a platform available, is it? So if the number of trains is greater than the number of platforms, it means that we cannot dock a train to that particular station as it were. So we return false. Otherwise, if it is not greater than or equal to number of platforms, then it means we have space for that particular train. So we are simply going to take that train and put it inside of the number of the trains array, as it were, right? And then we are also going to increment the number of trains since we've added a train to the array, as it were. On line 82, we have to increase or increment the number of the count, the number of trains that we currently have, and we are going to return true to signify that we were able to add that particular train into the array, as it were. So of course, you would go ahead and copy this code and paste it inside of the evidence document. Then moving on to item 3, we are going to, rather we are required to create a method called getTrains that's going to return a string. There are no trains if there are no trains at the station platforms. If there are trains at the station platforms, the method returns a string in the format. So the train at station that much are the trains at station, then we give the station ID, then we have that string, basically that formatted string right there. So essentially, wherever you see these angled brackets, we are supposed to replace those positions or those elements with actual values from our program at runtime. Then the line train number, train ID number on route number, then we specify the route is repeated for each train at the station platform. For example, if the station with the ID NT1 has 2 trains with the train ID numbers that much and that much, the method will produce this output. So the trains at the station NT1 are, then we are given the trains that are currently there. So essentially, this is the template, and this is sample output based on this template right there, is it? So we are to write program code for getTrains, and for that we should get 6 marks. So let's see what we have going on here, rather what I have going on here. So on line 87, we declare the method header for the getTrains method. Then on line 88, we are simply going to check to see if the number of trains is equal to 0. So if it is equal to 0, it means that we cannot get any trains, is it? Because there is no trains in the trains array, as it were. So we just return there are no trains. Otherwise, we are going to create a custom string right there. So we are going to call it result, and the template is that we say the trains at station this much are, then we can reuse that string to output any other train objects that we have inside of the train array, as it were. So remember earlier on it said that if you had, say, 2 trains, each line should say station what is it, the train ID, yeah, and the route, train ID and the route. So if you have let's say 5 elements, you would actually have to repeat on route number for all of the 5 elements that you have going on inside of your trains array. So that's why we have this string right there on line number 92. We are going to reuse that string for n, let's just say n objects that are inside of our trains array, as it were, because we don't know how many they are. So we are just having to call that method 2 times, 3 times, 7 times, whatever the number of elements that we have inside of the trains array. So on line 94, we are using a for loop that's going to run for the amount of trains that we have inside of our train array. Then for each case or for each run, we are going to concatenate the result plus the train, which is at current index position I. Then we get that train's ID number. Then we concatenate with on route number string right there. Then we get the train at that particular route, sorry, at that particular index position, as well as its route, as it were, is it? So essentially, we are now building this template right there. We are now building this template right there, which says we take the train ID, then concatenate with on route number, then we specify the route. So that's essentially what we're doing right here. So we get the train ID, then we get the route number, right? So this is going to be repeated for n times. So n could be 1, could be 5, could be 7, is it? Then eventually, remember, if you see on line 92, we declared this string called result. Then on line 95, we are now concatenating that result with the objects as well as the string that we have here, so that it's now one long string that we're going to then have to output later on. So essentially after doing that, we are going to return result as it were on line 99. Then of course you'd go ahead and copy this code and paste it inside of the evidence document. Then moving on to part D, the program is tested with 2 stations. So we have station ID and number of platforms. So these are the station IDs and these are the number of platforms. So we are to write program code to amend the main program to declare an instance of station for each of the 2 stations. So we are going to create 2 station objects, one with the ID STH and the other one with NTH and the respective number of platforms as it were. So let's go ahead and do that inside of the main method here. So you see that we do that right there on lines 15 and 16. So we create one station object called S1 and pass the respective arguments there. Then we also create another S2 object and then we pass the respective arguments as it were. Then of course you'd go ahead and copy this code and paste it inside of your evidence document. Then moving on to item number 3. So the 4 trains attempt to stop at the following stations in the given order. So this order is the one in which the trains are going to stop. So this one is going to stop at the first 3 trains are going to attempt to stop at STH, and the last one is going to try and stop at NTH. So we are to write program code to amend the main program to add each train to the given station using add train. Output station is full for any train where the return value indicates it cannot be added to the station. Then we are also going to output the trains at each station using get trains. Then coming to the implementation going on here for 2D, you see that we are trying to add the stations and outputting their destination, their stations. Sorry. So we are checking to see if take note that we have that not operator going on right before our condition. So initially we are trying to add S1 sorry, we are trying to add T1, that is the T1 object, to station 1, is it? So if this gives us a false, essentially that's what we are saying on line 19. If it doesn't give us a true, it means that the station is full. So we simply output the station is full. Otherwise, if it doesn't yield a false, then it means it's going to be added to the station. So we are doing that for the T1, T2, and T3 objects, which are targeting to stop at which are attempting to stop at STH, is it? So you see that we are doing that here. So T1, T2, and T3, we are attempting to add them to the S1 the S1 station as it were. Then we also do the last one for NTH for that train 21 VBC. So you see that we have the T4 object right there, the train 4 object, which is right there on line 12. So we are trying to add it to station number 2. So in the event that it's not added to station number 2, then we still simply output the station is full, right? So of course we would go ahead and copy this code and paste it inside of the evidence document as it were. Then the last aspect requires us to test our program and take a screenshot of the output. So let's go ahead and do that right here. So I'm just going to pull up my terminal, clear out the console. Then let's run the program and see what we have. So you see that initially it's going to say station is full. So the trains at station STH are, then this one, and this one, then the trains at station NTH are this one and that one. So yeah, of course you go ahead and copy this, rather not copy but take a screenshot of your output and paste it inside of the evidence document. And that brings us to the end of the implementation for question 2. I'll see you for the implementation of question 3.